Hello students. In the previous video, we learned the fundamental law of counting and permutations. In this second video, we will learn about the combinations. There are two types of counting techniques. Clear? In one, we are checking arrangements. Here we are talking means combination means we are doing selection. Clear? Remember, you need to turn. If arrangement is there, means permutation. If selection is there, it is combination. So first of all, we learn what is a combination. Combination is if means a choice. Choice means a selection of R objects from a group of n objects. There are n objects, many objects, and we are choosing less objects, R objects, without regard to the order. Clear? That means if there are 10 students in a class, I need to choose one student, then there is no order. Means I'm choosing elder one, younger one, who is having more height, who is fat, who is thin. Clear? There is no order. Without any order is called a combination. We call it combination of n objects taken R at a time. R at a time means if we have n objects and we are selecting n, we are making a choice of n. Choice means selection. Clear? So if we are making a choice of R objects from n, then it is denoted by NCR. N is the total objects, C means combination, R means number of objects we are making choice. So NCR, and the value of NCR is factorial n upon factorial R into factorial n minus R. Clear? Now we are making a group of this value. Why this value? Because you should remember this factorial n upon factorial n minus R was NPR. Clear? So we make the group of this 1 upon factorial R, we make it separate. So this value is, what is this value? It is NPR. So NPR upon factorial R. This is the value of NCR. I will tell you one of the value. For example, if you want to take, say, if we want to evaluate 5C3, what will be the answer? It will be factorial 5 upon factorial 3 and factorial 5 minus 3. This is factorial. So how much it is? Factorial 5 upon factorial 3 and 5 minus 3 is factorial 2 is equal to, what is the value of factorial 5? 5, 4, 3, 2, 1. What is the value of factorial 3? 3, 2, 1. And what is the value of factorial 2? 2 into 1. So 3 to 1 is 3 to 1 cancel. So how much we are getting? 5 times 4 is 20. Divide by 2 into 1 is 2. So the value is 10. So the value of 5C3, this is just example. I choose n is equal to 5 and R is equal to 3. So by choosing these two values of n and R, we evaluate and the answer is 10. This is just an example. I explained you how we can evaluate the value of 5C3. Okay, now we'll solve 4-5 questions and we will learn. It is number one, you need to fix in your brain that it is very, very easy. And we need to check whether it is arrangement. Arrangement means like seating arrangement. If you are going to a hotel with family, clear, it is a round table. Round table you are sitting. So you are sitting in a order. There is order. Okay, first father is sitting, then 3 boys sitting, then 3 girls sitting. So there is a arrangement, order in what arrangement they are sitting. But in selection, there is nothing. Clear? It is simple. We need to choose 3. So 3 means any 3, no problem. Whether they are male or female or, but if they are telling some condition, then you need to use that condition. Okay. So we are taking example number 1. What is example number 1? How many different ways? How many different ways to select? So that means, what is this? Selection. To select 3 people. 3 people. Committee from a group of 30. So you can think this question like as you in your college there are 30 teachers. Clear? There is a group of 30 teachers and the dean wants to make a team, a small team. So how many people he want to select? 3 people he want to select. So in how many ways he can select the 3 people out of 30? Clear? So if you see how many, what is the maximum number? Total number is 30. What is the value of R? It is 3. So 30 is the people, total people, and R is the number of people to form the committee. So total ways for selection. How many total ways for selection? It is 30C3. Clear? 30C3 means it is factorial 30, factorial 3 and 30 minus 3. And if you will check, it is 30 factorial upon factorial 3 and factorial 27. Clear? Now I will use one property here. What is that property? It is, okay, I will start here. 30, 29, 28, and this can be written as factorial 27. I told you in the previous lecture when I was explaining factorial that big factorial can be written as small factorial, like factorial n is equal to n into n minus 1 factorial. So big factorials can be written as small factorials. So similarly 30, 29, 28, this can be written as 27 factorial. And this is factorial 3 and this is 27 factorial. This 27 factorial cancelled by 27 factorial. And how much it is? 30 into 29 into 28 upon factorial 3 is 3, 2, 1. Now use your calculator and simplify this. You will get 4060 way. So if the college dean wants to select 3 teachers from a group of 30 teachers, then how many ways are there? There are 4060 ways to select a 3-member committee. Okay. Now another question is there. Example. A professor wishes to choose. Choose means selection. Choose 5 students from a class of 15 students. Clear? So how many possible ways are there? How many ways to choose? Clear? How many ways to choose? Means choose means selection. How many ways to select how many students? 5 students from a group of 15 students. Okay, so what is the value of n? The value of n is 15. What is the value of R? The value of R is 5. So total number of ways is equal to 15 C5. 15 C5 means 15 factorial upon 5 factorial, 15 minus 5 factorial. So this is 15 factorial upon 5 factorial into 10 factorial. Now expand it. 15, 14, 13, 12, 11, and this may be written as 10 factorial. Because big factorials can be written as a small factorial. 5, 4, 3, 2, 1. This is the value of factor 5 and factorial 10. This cancelled. Now use your calculator and multiply this and divide by this. How much you will get? 1001. So there are 1001 ways to select 5 students from a group of 15 students. Okay, let me write one question here. Okay, no. First we will solve this question. This is question number, example number 3. Okay. There are 14 men and 16 women in a community. So how many women are there? 16 women and 14 men in a committee. Clear? Now we need to make a committee. So how many ways are there to select? So selection is there to select. It is not selection, to select exactly 6 women and 6 men. Clear? So how many ways are there? If you see, number 1, select 6 men out of 14 is equal to 14C6, because there are 14 total and we need to select 6, so it is 14C6. Number 2, select how many women? 6 women out of 16 is equal to 16C6. Clear? So this much number of men we have calculated, and if you will simplify, you will get the value is 3003, and if you will simplify here, you will get the values is 8008. Clear? So this is separately, but we need to make a group together, 6 women and 6 men. So total possible ways. Total possible ways. Now you need to use fundamental law of counting. And what is that? If one work is doing in this number of ways, another work is doing in this number of ways, then the combined work will be done this into this number of ways. And if you will multiply it, you will get 24, 048 and 024. This much of number. This is big number. Okay. Now the last question. It is very simple. It is not difficult. Clear? So sometimes you need to check whether combination is there, permutation is there, or a mix of there. So next question we are going to study mix. In how many different ways? In how many? Question is in how many different ways? In how many different ways? 3 boys out of 10. Out of 10. 3 boys out of 10 can be seated on 3 chairs. Can be seated on 3 chairs. So in this question, if you see, there are combination, there are permutations. First of all, you need to choose 3 boys out of 10. This is to select 3 boys out of 10. The possible number of ways is 10C3. 10C3. Clear? This is number 1. Number 2 is can be seated on 3 chairs. Number of ways. Number of ways to sit on 3 chairs. So if you can see, if there are 3 people, we are choosing 3 people because 3 boys we are choosing. We are making a pair of 3. So how it will be? 3 pairs, we have choose 3 boys and there are 3 chairs. There are 3 chairs. So it is 3P3. Clear? So it is permutation because 3 chairs and 3 boys. First we are choosing 3 boys. Then there are possible ways to sit on chairs. That is permutation. Clear? Now total possible ways. Now total possible ways. So it is multiplication of both. It is 3P3. So if you simplify this, factorial 10 upon factorial 3, 10 minus 3 is factorial 7 into factorial 3 upon 3 minus 3 is factorial 0. If you will simplify this, it will be how much? 10, 9, 8 into factorial 7 upon 3 is 3, 2, 1 into factorial 7. And this you can keep 3, 2, 1, factorial 0 is 1. So factorial 7 is cancelled by factorial 7, 3, 2, 1 cancelled by 3, 2, 1. So how much it is there? 720 ways. So how many ways are there? Because one selection, you choose 3 students, 3 boys. So they are developing 3P3 possibilities to sit on 3 chairs. So you need to multiply the total number of selections with 3P3 and that is 720 ways. Okay, so this is about the total possible ways. So that's all, my dear friends, because it is a small topic. Thank you very much.